Hey guys, so today we're going to be working on standard 27, which is graphing equations in slope-intercept form. By the end of the video, you'll be able to identify the slope and the y-intercept. You'll also be able to graph equations already in slope-intercept form. Go ahead and pause the video and write this objective down. In standard 14, we took equations such as 6x plus 2y equals 10 and transformed them into equations y equals negative 3x plus 5. If you recall, we said that these equations on the left were in something called standard form, and these equations on the right were in something called slope-intercept form. We're going to learn today why it's called slope-intercept form and how we can use the slope and the y-intercept to help us graph equations of lines. Alright, so our definition for slope-intercept form is the slope-intercept form of a linear equation is y equals mx plus b, where m is slope and b is the y-intercept. Go ahead and pause the video and write this down now. So if you notice, the number that's being multiplied by x, in this case the variable m, that's going to be our slope. And the number that's being added or subtracted to our x term is going to be our y-intercept. Let's look at example 1 so that we can identify the slope and the y-intercept. Example 1 says to identify the slope and y-intercept. What I did is I gave you an equation y equals 3x plus 4. If we go back to what the slope-intercept form is, y equals mx plus b, we know that m is the slope and b is the y-intercept. You can see just how creative mathematicians were when they came up with this name. Okay, so if the number being multiplied by x is my slope, if I come over here and look at this equation, my 3 is the number being multiplied by x. Therefore, my 3 is my slope, or my rate of change. The number that's being added on is a positive 4. Do we see how I circled that sign in front of the 4? That's going to be very important in other problems. So our y-intercept is going to be positive 4. Alright, let's go on to example 2. Now that we're able to identify the slope and the y-intercept, we're going to go ahead and graph this line, y equals 2/4 x minus 3. The very first thing that we want to graph is our y-intercept. We can think of this as our starting point. So, if my slope-intercept form is y equals mx plus b, and b is my y-intercept, that means that negative 3 is my y-intercept. So, going back to our previous standard where we identified x and y-intercepts, we know that the y-intercept is a point on the y-axis. So what we're going to do is we're going to go to the point 0, negative 3, and plot that point. So I'm going to go over 0 and down 3. This is my y-intercept. We know that m represents our slope, so we're going to be able to identify 2/4 as our slope. If you recall from our rate of change standard, we know that slope is the same thing as rise over run. So we can use this fraction when plotting our line. We know that our numerator is our rise, so if we go from the point 0, negative 3 up 2, and we know that our denominator is our run, and we go over 4, 1, 2, 3, 4, we can plot the next point on our graph. We can now connect these dots, and we have graphed the line y equals 2/4 x minus 3. Example 3 asks us to graph the line 4x plus 2. So once again, our starting point is our y-intercept, or 2. So we're going to go to our y-axis and plot the point 2. And we know that our slope is the number in front of the x. Now this one's tricky. We know that slope is the same thing as rise over run. But when I look at my slope, I just see the number 4. If this is the case and you have only one number in front of your variable, what you can do is you can go ahead and write that as 4 over 1. 4 divided by 1 is the same thing as 4, so we're not really changing the number at all. We're just making it look a little bit different so that we can graph easier. So if I go back to my y-intercept, I'm going to follow my slope, which has a rise of 4. So I'm going to go up 4, 1, 2, 3, 4. And I'm going to go over 1 and plot my point. I can now connect those two dots. Ooh, I did not do a good job at that. Let me erase that. Ooh. So I have one point here, one point here. If I connect those two dots, I have my line. Let's go on to the third example. Example 3 is y equals x. So you might look at this and say, how am I supposed to graph this? Let's go back to our slope-intercept form, which is y equals mx plus b. Let's compare this to y equals x. If we want to know what our y-intercept is, it's the number that's being added or subtracted onto the x term. If I don't see a number there, I can assume that the number 0 is being added on. The reason why is this. If I add 0 onto my x, that is not going to change the right-hand side of this equation because x plus 0 is the same thing as just x. So what this tells me is my starting point is at 0, 0. I'm going to go ahead and plot that point. We know in math that if we don't see a number in front of a variable, that there is a 1 there because 1 times the variable is the same as just that variable. So what I have now is y equals 1x plus 0. We also know that our slope is rise over run. So if I see that my slope, my m, is 1, I can rewrite that as 1 over 1. So I'll go back to my starting point and go up 1 over 1, up 1 over 1. Connect those dots, and I now have my line. You'll notice that on this example, I went up 1 over 1, up 1 over 1 twice. On any of the previous examples, you can continue to do your slope to find additional points on your line. I just haven't because I didn't have enough room on my graph. But if you do have enough room, you want to put as many points as possible. Alright, so those are our 4 examples. Let's go ahead and go to the U-tries. Go ahead and pause the video now and try this problem. Alright, so first what we're going to do is we're going to rewrite y equals mx plus b. We know that b is our y-intercept, so that makes 1 my y-intercept. So I'm going to go to 1 and plot that point. My slope is 3 over 5. So I'm going to go up 3, 1, 2, 3, and over 5. 1, 2, 3, 4, 5. Plot a point. I'm going to go ahead and connect those two dots. And there's my line. Let's go on to number 2. Go ahead and pause the video now and try number 2. Just like the previous problems, I'm first going to start with my y-intercept, which in this case is positive 5. I'll go up to 0, 5 and plot a point. I'm going to look at the number in front of my x, and it's a negative 3. Just like on the previous problems, since I know my slope is rise over run, I'm going to go ahead and set my negative and have my negative 3 be written as negative 3 divided by 1. So this is different than the other ones because my rise is now a -3. So instead of going up +3, we're going to go down 3, -3, 1, 2, 3, but we're still going to go to the right a +1. The reason why is this. The number in my denominator, or my run, does not have a negative sign, therefore I know I need to go in the positive direction. I'm going to keep going with a few more points just so that we can see what that'll look like. So going from my second point that I plotted, I'm going to once again follow my slope, which is down 3, 1, 2, 3, and then over to the right 1, down 1, 2, 3, over 1. And I can connect those points there using a straight edge. And finally, example 3. Go ahead and, or practice 3. Go ahead and pause the video now. Okay, so this practice does not have a y-intercept that we see. So just like on the previous example, we know that we can add a 0 to this without changing that. That would make my y-intercept at my origin, or 0, 0. My slope, since I know that that's rise over run, and I have a -4, I can write that over a +1, and it stays the same. So going from my starting point, or my y-intercept, I'm going to go down 4, because it's a -4, 1, 2, 3, 4, and I'm going to move +1, 1 in the x direction. And I can connect these two dots. If you have any questions, be sure to write those down and bring them to class tomorrow. Have a great day.